So the midterm that we're going to be doing today is midterm 1 from fall 2018. Are they too loud? You can tell me if they're too loud. Loud? All right, here. Let's make an adjustment. I'm going to do my tutoring in the living room, and give me just a sec to set up, okay? Andy, I'm going to do tutoring in here. Is that okay? The waves are too loud. Dude, just do it in your own room. Cool if I like jack off. Dude, you're like on a hot mic, bro. People can hear you.
Why'd you mute yourself?
Because I'm talking to them, dude. Now they're gonna think you're weird.
I am weird.
All right. Here, actually, I probably should mic. All right, I'm gonna mute myself real quick. All right, yeah, this is pretty cool. Glad you guys heard that. Let's move on to fuck. Let's move on to the midterm that we're gonna go over today. So as I said before, if you guys pull up midterm 1 from 2018, we're gonna start from there. So I'll give you guys a few seconds to pull that up, and then we're gonna go ahead and get started.
I started blasting it before you.
Yeah. I swear to God, dude. All right.
For 10A.
Yeah, this is 10A.
They let you drink protein shakes on camera.
I inspire them to drink protein shakes. It's a smoothie, actually.
Are you muted right now?
No, I'm not. I'm not. It's fun though.
What time was it?
Fall 2018, midterm 1. And we're just gonna go over that one. So I mean, hopefully you guys have already looked over this midterm. I always encourage you guys to do as many as you possibly can. But I think that sometimes the answers can be a little bit confusing when you're looking at it on on the actual Gaucho space, like the answers that they provide in the solutions. So I'm just going to go over each question, maybe spend a little bit more time on it, and explain why the answers are what they are. All right, so let's get into it. Question 1 involves a bike with 2 wheels plus 1 frame, right? And so given this information, we have to come up with a utility function that's going to match what these preferences are, right? So you kind of have to ask yourself, well, what are some clues given the question that can kind of help me with this information, right? So hopefully you guys are kind of thinking already along the lines of perfect complements. So already that's going to allow us to eliminate some of the answer choices. I think right away you can eliminate B and you can eliminate C and D. So really it's just between 2 answer choices. It's going to be A and E. So I'll give you guys a few seconds, drop down what you guys think the answer is, and then I'm going to go over why the answer is what it is. All right, so I saw 1A, but I'm seeing a lot of E's. And I think that these are a little bit confusing sometimes when, especially you don't have a one-to-one pairing. You have to decide which one of the, I guess, coordinates, or if you want to call them like an X, Y, or good one, good two. You have to figure out which one of those is attached to the coefficient. So it looks like you guys did a pretty good job. The answer is E, and we're going to go over why that is. So the answer is E, where we have the utility between wheels and frame being equal to the minimum of 5W and 10F, right? So what this is just a monotonic transformation where we've essentially just scaled upwards. So nothing between the preferences themselves have changed, right? But what you'll notice is that we have 5W and 10F, right? As opposed to answer choice A. So here's answer choice A was equal to the min of 2W comma F. Whoops. And the way that I like to think about these kind of answer choices is if I had a bike, what I have, right, I would have two wheels and one frame. And so right from there, you're going to be able to plug in two wheels and one frame into this, this budget, or not this budget constraint, this utility function that we're given, right? And you want to see which of them makes it so that these two are equal to each other, right? So for example, if I were to go with answer choice A and I plugged in 2 comma 1, then what I would spit out was the min of 4 and 1, right? And we know that that doesn't make sense, as opposed to if we're working with this one, right? We plug in 2 comma 1, and what we get is 10, 10, right? Hopefully you guys are able to see that. So just be careful with how you're selecting your min functions. It's good to be able to narrow it down, but also there's a point in which you have to kind of plug in, right, the respective goods that you have, and that'll give you the correct answer. All right, so you guys did a pretty good job on that one. Let's move on to question 2. So this one doesn't really need to be explained on the board, but it's essentially which of the following must be true with satiated preferences. If you remember, satiation is one of those indifference curves that we talked about at the very beginning, where I listed an example. And so, yeah, so to answer your question, Andrew, and I think Becky answered that perfectly, is you want the stuff within, so x1 and x2, if you will, to be equal to each other. That's a really good question. But onto this satiation question that I have. What are some assumptions that we can make about them? Or like which of the assumptions is true? So go ahead and drop down your answer and what you think about this. This one should hopefully be a little bit quicker. So I'm seeing a lot of answers being B, and B is the exact correct answer that I'm looking for, right? Remember, with satiated preferences, if we have it something like this, where we have x1 and x2 right here, to say that something has satiation, right, in terms of its preferences, we assume that there's going to be this best point right here, right, where the closer you are to this point, the better off you're going to be. So basically, all of these indifference curves, as we move away from this point, are going to be or less preferred to each other. So the answer choice that there's a least preferred bundle is not true, because there could be equally as many least preferred as long as it's equally distanced, right, from the most preferred. There's never going to be a always positive or always negative marginal rate of substitution, because if you look at these indifference curves, right, there's some points in which it slopes upward, but there's also some points in which it slopes downwards, right? So those answer choices obviously aren't correct either, which leaves us with B, there being a most preferred bundle, right? So that is exactly right. let's move on to question 3. So question 3, I'll give you guys some time to read it out for yourselves, and then we're going to go over the answer in maybe like 30 seconds to a minute. And I'm just going to be writing it on the board so you guys can kind of check my work. All right, so go ahead and drop down your answers whenever you guys kind of wrap up with this question. All right, I'm seeing some E's rolling in, seeing more and more E's. So you guys are correct, and let's just go over kind of the work that you're going to want to show. I guess with it being multiple choice, you don't technically need to show it, but these are the steps in which you should be taking when you answer a question like this, right? So immediately off the bat, we can recognize that we have perfect substitutes, right, in terms of what kind of utility function we have. And so that's going to tell us that in most cases, right, except for a very special case, we're going to be either consuming all of x1 or all of x2, and that's going to be dependent on the relationship it has to the MRS, right? So I like to draw it out, right? Here is my x1, here is my x2. You're technically going to be able to consume 16 units of x1. That's just 80 over 5, right? And you're going to be able to consume 10 units of x2, right? That's just 80 over 8. So you draw a line that connects like that. And the slope, right, is just going to be 5 over 8. Or I guess negative 5 over 8 since it's downward sloping. And so given this information, we have to relate what we know about our budget constraint to our indifference curves, right? We know that the MRS is just going to be the marginal utility of good 1 over the marginal utility of good 2, which means it's going to be 1/2 everywhere, right? And so we want to see, or I guess negative 1/2, technically. And so we want to see, right, how much of each, or I guess what rate, right, gives us a MRS of 1/2. So we know that 10 going to 20 would give us a rate of 1/2, as would 8 going from 16. So I know that can be a little bit tricky to kind of think about conceptually, but essentially what's going to happen is these are the slopes of our MRSs. And if you'll notice, the slope of our budget constraint is actually going to be steeper than the slope of our MRS. And we know that when that occurs, we're going to consume all of good 2, right? And when we're consuming all of good 2, that means that $80 is going to be spent on $8 a piece. So we're going to be able to afford, so all x2 implies 80 over 8, which is going to be equal to $10, or 10 units, right? And you guys can see that 10 is not one of the given answer choices, which means that the answer is E, none of the above. I've said it before, but I'll say it again. They're not afraid to use the all of the above section or answer choice. So if you have an answer that you're confident in and you don't see it, I definitely wouldn't be afraid to select all of the above. All right. I feel like everybody was pretty comfortable with that one. So let's move on to question number 4. Or question, is that 4? No, question, yeah. Let's move on to question number 4. So I'll let you guys read that also. I'll give you guys maybe 30 seconds to a minute. and I'm gonna write down how I would solve it, and then we'll kind of come back together, and we'll regroup and talk about the answer. All right. I believe that's been enough time for question number one. So, or question 4, I guess, or question 1 of this kind of set. So why don't you guys go ahead and drop down what you guys think the answer is in the chat below. All right. I'm seeing a lot of B's. All right. And you guys are absolutely correct. The answer choice is B. The MRS at the 0.44 is going to be 1/4. And so here's kind of how I showed my work for this question. You guys can see that what we're dealing with here is a quasi-linear utility function, right? So we talked a lot about quasi-linear on Monday, and so hopefully you guys are pretty familiar with it, right? That being said, the MRS, we solve it just like we would normally solve any MRS, right? We find the marginal utility of each good, and we find that ratio, right, of x1 over x2. And so in this case, what we end up with is 1 over 2 times the square root of x1. And so when we plug in 4 comma 4, right, we plug in 4 for x1, and we get 1 over 2 times the square root of 4, which is just going to be 1 over 4, right? Something that I think is of note with this question is that the MRS is always going to be 1/4 when the x1 value is 4, right? So the MRS of 4 comma 4 is going to be equal to the MRS of 4 comma 10 or 4 comma 15 or even 4 comma 100, right? Because of the fact that, right, I just want to remind you that with these quasi-linear MRSs, we're only going to have one of the variables being present in our MRS, right? So that the value of our MRS is only dependent on that one single variable. So just keep that in mind, guys, and don't let that kind of trick you guys on a test. But you guys do seem like you're pretty familiar with this, or you feel pretty comfortable. So let's move on to question 5. And this is essentially finding the optimal bundle. And so we're asking how many units of good 2 will this consumer purchase to maximize her utility, right? So I'll give you guys another 30 seconds to a minute, and then we're going to go ahead and solve this question. All right, and once you guys start getting your answers, go ahead and put that down in the chat. All right, let's see what you guys have to say. All right, I'm seeing a few A's in your answer. Let's get a few more answers to start trickling in. All right, so I'm seeing a good amount of A's. A is the correct answer choice, so let's get an explanation as to why the optimal amount of x2 is going to be equal to 1, right? So let's go back to where we left off, right? Where we left off is going to be a good starting point for how to eventually finish this question, right? So we found what the MRS was, which we used for question 4. And now, actually, let me just change this so you guys know. This is going to be for question 5. One thing that we do need to prove is that we do have DMRS, right? Which is going to be the kind of the criteria to set our MRS equal to our price ratio. We check that we do, right? So as X1 increases, our MRS decreases. So that tells us that we have DMRS. And so from here, I set my MRS equal to my price ratio. And I'm able to solve for X1, right? And remember what I said? We're going to be able to solve for the variable inside of our MRS straight from setting it equal to the price ratio. So this is already going to be our optimal amount of X1. But if you guys, right, remember to read the question carefully, they're not asking for the optimal amount of X1, they're asking for the optimal amount of X2. And so from here, what we have to do is just plug everything back into our budget constraint. And you'll see that we only have one unknown, and that's going to be X2. And so from there, we just rearrange and move some stuff over, and we get that X2 is going to be equal to 1, right? So these are steps that you should be familiar with already. You've done them probably 100 times, but it can maybe be a little different with quasi-linear. So this is just me telling you that even though they may look different, quasi-linear utility functions really are very similar. So Andrew, to answer your question, X1 star just refers to the optimal amount of X1. So X1 can be any amount of good one that we have, but X1 star implies that you've optimized, right? So in this case, X1 star would be 64, which implies that 64 is the optimal amount of good one. Does that make sense?
Yeah, thank you.
Yeah. All right, awesome. Okay, so we've gone over the multiple choice questions. Now, moving forward, we have some free response questions. So I know that the kind of the format of the test is multiple choice, I believe. So that being said, you know, I do think that it is really important for you guys to kind of treat these as multiple choice questions because they could definitely be asked in that way. And so Giovanni, to answer your question, if, for example, we did not have DMRS, that would imply that we're going to be having a corner solution, right? Where we're either going to have all of one good or all of the other. So you'll typically see something that doesn't have DMRS, right? So in this case, right, if X1 had been squared instead of the square root, we would have seen something without DMRS. And we would have consumed all of X2 or all of X2 or all of X1 based on which one provides the most utility. Christopher, this is midterm 1, fall 2018. Okay, so let's go over these free response questions that we have. So this is question 6. Let me just erase the board and then I'll get right into that. All right. And so before I go over the answer, I just want to make sure that you guys are, yeah. So that's what I was kind of thinking when I was writing this answer choice, or this answer kind of question, is that you guys do need to have some familiarity with normal goods, ordinary goods, inferior goods, and giffen goods, which you don't need to have for midterm one. So um, I'm just going to kind of give you guys the definition for normal income. And then from there, I think that the question is something that still is going to apply towards your midterm that you're going to take. So just for definition's sake, we consider a good normal is when basically your consumption of one good. So we're going to consider good one to be normal when consumption of that good increases as your income increases, right? So I'm going to go a lot more in depth into this starting next week. But I think that given this information, you should be able to kind of answer this question. And I'll work alongside you guys with it. But essentially, you can think of a normal good as being any sort of kind of thing you consume in your everyday life, right? So maybe a car. If you have more income, right, you're going to consume more cars. So think of stuff like that, right? Clothes. If you have more income, you're going to consume more clothes. Most everyday things are normal goods. So I'll kind of leave it at that because I don't want to get too far into it just because I don't expect it to be on your midterm. But this is still a question that is really applicable towards the material that you should know, okay? And I spelled normal wrong right here. There's an R. So with that being said, for what level of M, so for what income levels will good 2 be normal, right? Well, we know that a good is normal, right? When as our income increases, so does our consumption of that good increase. And I think that you guys might be thinking, well, X2 is a good, which means that it's always going to be a normal good, right? And when I say that it's a good, I mean that it provides positive marginal utility, right? So you're probably thinking, well, it's always going to be a normal good. But that's not always the case, right? Because of the fact that we're dealing with a quasilinear utility function, right? And the thing about quasilinear utility functions is that we're going to consume all of x1, right, before we start consuming any of x2, right? So for those periods, right, where we're still consuming x1, x2 is not technically normal yet, right? And so that's going to be the clue that I'll give you guys. And I'll give you guys maybe a minute or so, and then we'll come back and we'll answer this question together. Okay. Okay. 2 over x1. Okay, so the reason why, and I kind of, this is something that kind of confused me when I went over, I guess it was a question maybe a week ago or a week and a half ago. I think it was last Monday. But I wrote an email to you guys kind of clarifying what went wrong. But essentially, right, we know that the marginal utility, or I guess the partial derivative of this function with respect to x1 is just going to be 4 over x1, right? And when we divide by 2, which is something that I kind of messed up on, right? What you're really doing when you divide by 2 is you're multiplying by the reciprocal. So it should be 4 over 2x1, which is going to cancel out to being 2 over x1. So hopefully that kind of clarifies things. And I guess that since this question isn't multiple choice, I'm not going to wait for answers to start rolling in. But I do think that this has been enough time. Yeah, here. So say that we have actually 8 divided by 6, right? Say that we have 8 divided by 6. What this really is 8 over 1 divided by 6 over 1, right? Which can be a little bit confusing, right? And is not good for the eye. So what we do right here is we're actually multiplying by the reciprocal of 6 so that we get 8 over 1 times 1 over 6, which is equal to 8 over 6, right? And you can kind of expand that out to stuff like this, where maybe the denominator is not 1. Say that it was x1 in this case, right? It would still be looking like that. Does that kind of answer your question? And does that make sense to you? Yeah, exactly. But basically a whole number is, you can think of it as a fraction with just denominator 1, right? And so if you extend that to when the denominator isn't 1, the thinking still applies. All right, so I'd say that that's been enough time to kind of absorb what the question is asking you and then come up with an answer, right? So I admit that this question would have required some knowledge of the different kinds of goods that are out there. So normal, ordinary, inferior, and giffen. And those are all things that you're going to learn, trust me. But for now, I gave you guys a hint that a good is normal when as income increases, so does consumption of that good, right? And the key thing is that we're dealing with a quasilinear utility function, which tells us that we're going to consume all of our one good, which in this case is going to be x1. We're going to consume only x1 up until we reach that optimal amount of x1, and then we're going to start consuming x2. So in this scenario, you're going to treat the question exactly right, how you normally would, where you find the MRS, you check to see if there's DMRS, which it does, and then you set it equal to your price ratio, which is 2 over 6. And so from here, we get that the optimal amount of x1 is going to be 6 units, right? And this is found just by setting it equal to the price rate, or to the price ratio, which is something that I've kind of said a few times at this point, right? But now that we've found our optimal amount of x1, right? That tells us that we're gonna use our income only towards x1 up until we hit those 6 units, right? And so once we've hit those 6 units, we're gonna stop consuming x1 and we're gonna shift all of our consumption towards x2, which is gonna fill that definition that as income increases, so does our consumption of good 2, right? Because if you think about it kind of in terms of the definition of a normal good, good 2 was not normal while we were still consuming x1. Does that make sense? Hopefully it does. It's not imperative that you know what the kind of goods are, but it's like the thinking behind it that I think you guys are really going to want to kind of walk away with. So that's it for question 6. Let's move on to question 7, which is something that I don't believe will require you to know any other good, or will require you to know stuff that you don't know already. So kind of like the other questions, I'm going to give you some time to write down all the information and maybe come up with an answer or a preliminary answer. So I'll give you guys 2 to 3 minutes for that while I work through it as well. And then we're going to go back and we're going to talk about it. Okay, all right. I think that that's been enough time. It's been the 2 to 3 minutes that I kind of talked about. So let's go ahead. Actually, first off, which should she choose? Should she choose to rent a car or should she choose to take the taxi everywhere? Oh, dude, freaking knees, man. Okay. All right. So I've seen a few people say rent a car, and you guys are correct. And so now we're just going to go over why it is that you are correct. So let's take a look at, first off, our utility function here is x1 over x, or x1 times x2, which is going to be a perfect Cobb-Douglas, right? We're given that she has $1,000 to spend, but now she must make a decision, right, between either taking a taxi everywhere or renting a car, right? So if she rents a taxi, then every mile that she goes is going to be a price of 2, right? And the reason, oh, actually, hold on. This should be P2. So I think that's what you were asking about, Andrew.
Also, isn't the MRS just 1?
So the MRS is x2 over x1. So the reason why, what was that?
Sorry, again.
Well, the MRS is just going to be x2 over x1 because if you take the marginal utility of good 1, you're left with x2, and if you take the marginal utility of good 2, you're left with x1, right?
And don't both of those... I'm just not seeing where the 2 over 1 comes in.
The 2 over 1, oh, okay, I see what you mean. The 2 over 1...
You're setting it equal to the price ratio.
Yeah, exactly.
I see. I thought it was simplifying. I was like, what? Okay, I got it.
No, yeah. This is just because of the fact that I have DMRS, I'm now going to be able to set it equal to the price ratio, right?
Yep.
And the key thing is knowing that P2 is going to be equal to 1 in both scenarios. And that has something to do with the fact that it's a composite good, which I never really covered, and it's more of a definition. But pretty much when you're consuming on everything else, right? The whole term like consumption on everything else, you automatically set the price to 1. I'm not sure why they do that, but it's just kind of best practice that is done in this class. So yeah, Stephen, to answer your question, you're only going to be able to set it equal to the price ratio when you prove that you have DMRS, right? Because that implies that you have those strictly convex and strictly declining indifference curves is when you have DMRS.
I have a question.
Yeah.
So for example, your MRS on situation 1, right? X2 over X1. Well, that is the MRS for the Cobb-Douglas. But the reason it's DMRS, when you do the DMRS test or the MRS test here, you're still taking it as the value of X and the value of Y being value of X is X1 and the value of Y is X2, or you're just taking it as is where X2 equals X and X1 equals Y?
No, so it really doesn't matter how like you want to interpret the variables, as long as you have the one being in front and the one being after, right, in this order, right? So to kind of answer your question, typically on an XY axis, we would think of this being X and Y, right? In this case, it's just X1 and X2, right? So X2 in this situation is meant to represent Y in that case. So you can think of Y over X.
Y over X. So the MRS test, does that stay the same where we look at how X changes, meaning X2, and check to see if it's emission?
So the MRS test is a test to see whether, right, I'm going to use X1 and X2 just because that's what I have it in this context, right? The MRS test is to see whether as X1 increases, right? So you think of a graph like this, and you have your indifference curve like this. You want to see, right, as we move along this axis, or as we move down this axis, that my MRS, which is the slope of my indifference curve, if you remember, right, is going to be decreasing, right? Essentially, it's going to be getting flatter as we move kind of in these directions that I pointed out.
Talking about because we're taking as a whole, right? How does the whole change as X or Y go down?
So as X goes up or as Y goes down, yeah.
For the whole.
For the whole MRS, right? Which is
right. Okay, but then I just thought because it's Cobb-Douglas, we can assume it has a DMRS.
Yeah, so all Cobb-Douglas will have, all Cobb-Douglas will have DMRS, right?
Okay.
But it's still something that you're going to want to prove or show to yourself. Okay.
Hi, how do you get x2 equal to 500 when at the bottom right it's 400?
So these are kind of broken down into situation 1 and situation 2, right? Which I'll get into in just a minute. So kind of going back off of where I left off with situation 1, I've proved DMRS, which means I can set it equal to this price ratio that I have right here, right? And this becomes like a really easy optimization problem that we've probably done like quite a few times at this point, where we're able to plug in a value of x2 into here, right, which is in terms of x1. So now I have 2x1 plus 2x1 is equal to 1,000. And so 4x1 is equal to 1,000, meaning that x1 is equal to 250. But we also know that the relationship between x2 and x1 is that x2 is twice the amount of x1, right, given by this. And so then you just multiply x1 by 2, and you get 500.
Okay, got it. Thank you.
Right? And the reason why situation 2 is different is because in order to rent a car, there's a $200 upfront fee, so that you're only going to be left with $800 after. And so from there, right, you do the same exact process. You set your MRS equal to your price ratio, and then you substitute x1 or x2, right, either one, into your budget constraint, and you get that x1 is equal to 400, which is the same as being x2 being equal to 400, right? Because these two are equivalent, so they're both going to be equal to 400, right? To kind of go back to what you were saying about that. And yeah, Stephen, it doesn't matter. Connor, I wouldn't exactly think of it that way because of the fact that technically you could get 1,000 miles out of here, or 500. I guess no, you get 500. I wouldn't think about it that way, but if it works, it works, and I'm not gonna tell you not to. But yeah, I think that might not always be the case, but I could be wrong. So basically, it comes down to which is greater, 400 times 400 or 250 times 500. I don't have a calculator on me, but I guess you could straight up multiply. I just know from experience that this is greater. So on a test, you would have to just multiply it out. So hopefully you don't mess that up. But essentially, you find that situation 2 yields a higher utility, right, when you factor in x1 times x2. So hopefully that made sense to you guys. If there's any questions about that, feel free to ask me right now. I'm more than happy to answer any questions that you have. And yeah, aside from that, I do have drop-in hours tomorrow, or actually at 2 o'clock today. I'm not sure when your guys' test is tomorrow, but I also have drop-in hours tomorrow at 1. So if you guys have some last minute questions, it's in the morning. So I don't know if you want to hang out with me at 1, feel free. But I do
7:30.
Yeah, okay. But I do have drop-in hours today after. But yeah, if there's any questions, definitely let me know.
How do we know? How do we get the link for drop-in hours? Is it the same link for this one?
It's in my calendar, but I think that it might be on the Gaucho Space page that we have for 10A for CLAS 10A. Oh yeah, also
Okay.
this video will be posted, so if you have any questions about a specific question that I went over, feel free. Otherwise, you guys are good to go. I know that I typically go over a little bit on time, but
tomorrow, can we ask you about the economics in action question?
I'll be quite honest with you. I have no idea what economics in action is.
Okay.
When I took this this class, it was basically just 2 tests and a final. But now that they've added a lot of stuff, so I'm not sure if I'll be any help with the economics in action. You could definitely
Okay.
ask me, and
Okay.
I'll try to answer.
All right. Cool.
Christopher, all my previous Zoom meetings have been posted, and this will probably get posted within the next 30 minutes. Okay. All
I
right.
had a question about the Cobb Douglas. Real quick, if you have time.
Yeah. No, I have time.
Okay, for sure. So I like saw examples of how like when you're like rearranging the P of X over Py equals MRS. Like I've seen examples where it's like you plug it into the P1 over P2, and then I've seen examples where like it's the actual like price like 2/1. So I was wondering like when you would do like each one.
Yeah. So the way that you're talking about it is when it's left in like general terms. So when it's left in general terms, I think that there are instances in which you'll need to make it general, but I personally like working with numbers that I can actually kind of visualize and see for myself, as opposed to it just being like a variable.
Yeah.
But the point of the general solution is that you can plug in hypothetically any values of those variables, and it'll provide an answer for you. So I think personally, if I get numbers right away, I like to plug them in right away. But you'll get the same answer regardless.
And that's with like that's not just with Cobb Douglas, right? That's with like everything kind of.
Yeah, I mean anything as long as you do the general solution correctly, we'll get you the same answer. The only reason I prefer to plug in numbers right away is that I find that when I just have variables, I can get kind of tripped up and I won't get the correct general solution.
Yeah.
So
That's why I was just wondering, like, if there's 2 ways of doing it, or if like I was kind of confused on that. It's like sometimes there's just numbers, and sometimes there's general solution or whatever.
yeah, so if you do have numbers given to you, you can honestly plug them in at any point that you want throughout the question, and you'll get the right answer. But it's really just about making sure that the steps are correct.
Gotcha. Okay. Thank you so much.
Yeah, no worries. All right.
Is that? Can I ask one more question?
Yeah, of course.
For a demand function, the demand function has to have P1, P2, and M in it, right?
So that's
Like
actually
if it's missing one.
that's actually a good question. It doesn't have to have all of those variables in it, but it can't have more than the variables that are given, right? So, for example, I could hypothetically get a demand function that's in terms of P1, P2, and M, but it's only equal to M over P1 squared or something like this, right? Or to make that more correct. I don't believe that you'll see many where you don't have all three, but basically you don't have to have all three, but you can have more than the three that are given here. So you can't have something like this, right? Because this is not a variable, that's an input.
Oh, okay. So you can't have the value that you're solving for, that you're looking for. Like you can have an x1 in here because you're looking for the x1.
Yeah, exactly.
Right.
Or it could have even been x2 or something like that.
Yeah.
What I'm trying to say is that these are the inputs that you're given, but they don't always need to be present. But you also can't have more than the inputs that you're given.
Oh, okay. So you can't have x2 in there because it's not in the.
Because it's not one of the inputs, right?
What about can m be squared? Oh yeah, m can be squared. You squared it over here. Okay.
Hypothetically, I mean, you really won't see many demand functions like this with the utility functions that we're working with. But, hypothetically, this is possible. I think it would follow scalar invariance. If you want to do that test, you can see for yourself. But yeah, it can be squared.
All right, thanks.
All right. Any other questions?
Yeah. If you're doing homogeneous degree of 0, does the bundle have to be P1, P2, and M all included?
So I wouldn't. This isn't a bundle, by the way.
But
Just to clarify, these are inputs, right? That you can plug in actual numbers, right, into these inputs, and you'll get a demand or quantity demanded from our demand function.
So like if we're doing a homogeneous degree of 0 problem and you have that first part how it is, and so you plug in lambda for the test, but then the equation that you're setting it equal to is the one you have there, 2m squared over p1 squared. You wouldn't have p2 even though it's included in the inputs. So
yeah, so because there's nothing to attach a p2 to, you just wouldn't have it show up here.
So is it okay? So would you still do the test, and then if the lambda's
yeah, you would still do the test because
p2 is not included?
Because you can think about it, right? If my quantity demanded is not a function of P2, meaning that P2 has no effect on the amount of quantity that I'm going to demand, then in this situation, when I double it, that's going to also have no effect on the quantity demanded.
Oh, I see. Yeah, that makes sense. Thank you.
Yeah.
Would the demand function have a m in the denominator?
Huh?
The demand function, can it have the m in the
so
denominator?
I don't want you guys to get too caught up in the way that I have it formatted here. It can show up in any format, right? Any sort of arrangements, as long as it follows homogeneity of degree 0 or scalar invariance, right? Which are the same thing.
All right.
Okay. Kyle, to answer your question, if you go to my drop-in hours, I can do a coupon example. Albub, to answer your question, convex Cobb-Douglas, I believe, will always be strictly convex. That's like kind of the defining feature of them. Yeah. So I've reached my time. If you guys still have any questions, feel free to join me in my office hours, but or I guess my drop-in hours. But yeah, this is it for today. If I don't see you guys there, good luck on your midterm tomorrow. I wish you guys the best of luck. So yeah.